Hello again to everybody. For today, we have one more section to discuss, and this is entitled Invalid Argument or Invalid Arguments. In the previous lessons that we have considered, we've been looking at arguments. And a quick review, we have said that whenever we are considering an argument will consist of two parts. It will have our premises composed of several propositions, and then we have our conclusion. And since we have mentioned before that we will be dealing with deductive arguments, deductive argument basically means that the conclusion is definitely derived because of the premises. Okay? And that means that our argument will become a valid argument, that is, if each premise will have a true value and that the conclusion will also have a true value. So that's what we have done before. Since we want now to look at an argument that is invalid, what will now be the difference between an argument that is valid and an argument that is invalid? If we will now consider an invalid argument, we can say that for a deductive argument, the argument will become invalid, that is, if the conclusion cannot be derived based from the premises. Therefore, if for a valid argument, all the premises are true, the conclusion is also true, for the invalid argument, what will happen here is our premises will be true, but this time our conclusion will now be false. Again, an argument is invalid if the conclusion cannot be derived based from our premises. So in other words, our conclusion is false and the premises is true. Therefore, if we will just base it from this section, what an invalid argument is, this will imply now that if we want to show that an argument is invalid, we can start off by setting the conclusion to get a false value. And then if we can show that each premise can be true based from the propositions involved, then the argument is invalid. Let me give an example for you to have a better understanding for that one. Example number 1. Let's say we have our first premise as P implies Q. And then let's say our second premise is Q. And let's consider our conclusion to be P. Now, if we want to verify whether this argument is invalid, we will now force the conclusion to have a false value. Therefore, since we only have two propositions involved here, let's now try to consider some truth values for these propositions so that we now obtain our desire to force the conclusion to be false and to attempt to see whether each premise can be true based from those truth values. Now, looking at this example, since we are now forcing our conclusion to be false, then we have no other choice but to set our P to 0 so that the conclusion is false. Now, going now to our premises, we want to make each premise to be true. So, if we want now the first premise to be true, clearly, if P is false, since this is a conditional statement, then this entire proposition will be true regardless of the value of Q, because P is false. Remember, if we have a conditional statement, if the if clause is false, automatically the entire proposition is true. Okay? So, this first premise is true if P is false. Now, since Q can still have any value in the first premise, whether it's true or false, the entire premise will be true since P is false. So, we are still undecided whether to use 1 or 0 for Q. But based from the first premise, if Q is 1, Q is 0, the entire premise will be true. But the second premise must also be true. So if the second premise will also be true, then we have to set our Q be 1. So if Q is 1, then the second premise is true. So if you will double check, P is 0, therefore the conclusion is false. P is 0, 0 implies if Q is 1, Q is false, Q is true, P is false, therefore this must be a true value. And then Q is true, then the second premise is also true. You will now find here that if we now set P is 0, Q is 1, the first premise is true, the second premise is true, and the conclusion is false. Thus, the argument is invalid. So that will be the process. Thus, the argument is invalid. If you want to push through with this conclusion, thus the conclusion is invalid if is 0, Q is 1. Or P is true, Q is false. Q is true. P is false, Q is true. So that will be the process. Again, for an invalid argument, we will force our conclusion to be false, and we will attempt to make our premises to be true. If we can show that the conclusion can be false, each premise can be true based from some truth values of our propositions, then the argument is invalid. Another example. Let's have another example. Second example, first premise. We have P implies Q, not P for the second premise, and then our conclusion is not Q. We have again two propositions involved. Two propositions involved, P and Q. We want to force our conclusion to be false. Therefore, if we want the conclusion to be false, then the value of Q must be true because our conclusion is not Q. Therefore, if Q is true, then not Q will be false. So, Q is true. Next, we want each premise to be true. Let's go first to our second premise. We want this to be true. So if we want now our second premise to be true, then P must be false. Because if P is false, then not false must be true. Okay, so we now have the possible values for P and Q based from the conclusion, based from the second premise. Now let's check our truth values for P and Q under the first premise. So under the first premise, this is a conditional statement, if then, or implied. P is false. Anong sabi natin noon? If we are considering a conditional statement, if the first proposition is false, automatically the entire proposition is true, regardless of the value of Q. Okay? So, what is the significance of this? We have shown that if P is false and Q is true, then premise 1 is true, premise 2 is true, but the conclusion is false. Therefore, the argument is invalid when P is false, Q is true. Okay? So that's another example of an invalid argument. Let's look at the third example. First premise. P or Q and R. And then the second premise, not P and Q. And then followed by the conclusion, therefore R. In our argument, we have three propositions involved. We have the propositions P, Q, and R. If we want to verify if this argument is invalid, again, we will force our conclusion to be false. Therefore, if our conclusion is false, then R must be 0 because we want the conclusion to be false. Next, we want each premise to be true. We want each premise to be true. And what do we have here? Since we want each premise to be true, let's look at the first premise. The first premise, why are we looking at the first premise? Because the first premise involves R. The second premise does not involve R. And since we have already the initial value for R, which is false or 0, then let's consider the first premise. If R is 0, so this is now having a false value. If R is 0, since this is a conjunction, then regardless of the value of Q, this entire thing here will be false. Again, Since R is false, this is a conjunction. Therefore, Q and R, regardless of the value of Q, will be false. So, up to this point, we don't know whether Q is true or false, because regardless of the value of Q, this entire thing here will be false. Now, if this entire thing here is false because R is false, then for the first premise to be true, P must be true. Why? This is a disjunction OR. Since this entire thing is already false, for this whole premise to be true, then we have no other choice but to set P to be true. Okay, so we're done with premise number 1. Now, for premise number 2, we want this to be true also. Okay, if this is true, if premise number 2 must be true, what do we have here? P and Q. P is already given. P is true. So, remember, this is a negation. So, if this is a negation of this entire proposition here, then the second premise to be true, P and Q must be false. P and Q must be false, so that when you negate a false value, it will give a truth value true. But P is already true. Okay, so for this to be false, Q must be false. Because if Q is true, true and true will be true. Not true will be false. But we want the second premise to be true. Therefore, P and Q must be false. And for P and Q to be false, since P is already true, then Q must be false. Okay, so let's double check again. If P is true, Q is false, P and Q will be false, not false will be true. Okay, for premise number 1, P is true. This is an OR. So regardless of the value of this second proposition here, first premise will be true. And of course, R is 0, R is false. Since each premise is true and the conclusion is false, our final say here will be, thus, the argument is invalid. And this happens when P is 1, Q is 0, R is 0. Okay? So that's the third example. Let's have a fourth example. And the fourth example that I'll be giving is the example given in your module. Let me just explain that. Though the answer or the solution is already in your module, but let's discuss this for you to be able to understand it better. Hopefully, for you to understand it better. So premise number 1, we have K implies L. Proposition 2, K implies not L implies M. And then proposition 3, L or M implies N. Final line, which is the conclusion, J implies N. In our argument, how many propositions do we have? We have J, K, L, M, N. 5 propositions all in all. So when proving if an argument is invalid, we always go first to our conclusion. And we want to make our conclusion to be false. And how do we make our conclusion to be false? We now choose truth values for the propositions involved in the conclusion to make it false. This is a conditional statement. Since this is a conditional statement, we cannot set J to be false. Why? Because we have mentioned before that if we have a conditional statement, if the first proposition is false, automatically this will be true. So J cannot be false. If J cannot be false, then we have no other choice but to set J to be true. If J is true, N cannot be true, because if true implies true, the entire statement will be true. But we want the entire statement to be false, therefore, we must set N to be 0 or false. So true implies false, that will give us a returned value of false. Okay, so we have already the value for J, 1, and we have the value of N, 0. Now let's go to our premises. We want each premise to be true. We want each premise to be true. Let's proceed with premise number 1. Okay? Since we already have the value of J, we have the value of J. So let's proceed with premise number 1. We want this to be true. We want this to be true. Since J is 1, if you want, we can write that here. I hope this will not confuse you. Let me just rewrite premise 1 here. J implies K implies L. Remember, we want this entire proposition to be true. But J is already true. This is an implication. For a conditional statement to be true, if the first proposition is true, this entire thing must be true. And for this entire thing to be true, this is again an implication, we can set K to 0. Okay, again, we want J implies K implies L to be true. But since J is already true, then for this entire thing to be true, we need K implies L to be true also. And for K implies L to be true also, since we still don't have the value for K and L, we can set K to 0. If K is 0, regardless of the value of L, this will be true. So we're done with this. We're good with that. Let's go to the second premise. We want the second premise to be true also. To make the second premise to be true, we have already set here K is false. If K is false, look at this. K is false. This is an implication. We're done. The second premise will definitely be true regardless of the value of L, the value of M. Because this is an implication, K is false, then this entire proposition is true. Okay, so regardless of the value of L and M, second proposition is true. Now let's go to the third proposition. We want the third proposition to be true. Okay, for the third proposition, what do we have? We have L or M implies N. Remember, we want the third proposition to be true. We want the third proposition to be true. And the third proposition to be true, look at our chart first. We already have set N to be 0. So, if N is 0, since this is an implication, N is 0, this is an implication. If we want this to become true, then it should mean that this must be false. Because this is an implication. Why? If L or M becomes true, implies false, then this will become false, which is what we don't desire. Because what we desire is to make the entire third proposition to be true. Therefore, we want L or M to be false. Do we know the value of L or M? No. We don't know L, we don't know M, because based from the previous premises, we have said that we can have any value for L and M. Okay. Therefore, let's just set the values of L and M based from the third proposition. We want this to be false. This is an OR. Therefore, when is the value of the disjunction equal to false? Since this is an OR, both must be false, because if one is true, this entire thing will be true. If both are true, this will also be true. Therefore, that should force us to make L and M, the value of L, the value of M, be false as well. Okay, so let's double check. Let's start from the conclusion. We're now looking at these entries here. J is true, N is false. Therefore, the entire conclusion is false. Go now to proposition 1. J is true. This is an implication. Therefore, if K is false, this will be true. True implies true will be true. Check. Premise number 2. K is false. This is an implication. Regardless of the truth value of not L implies M, this entire proposition is true. Third proposition, L is false, M is false, false or false is false. False implies N is false, this would still be true. Since we have the conditions satisfied, what are the conditions? The conclusion is false, each premise is true, then the argument is invalid. So, thus, the argument is invalid. Invalid. When what's our value? JKLMN. When J is 1, K is 0, KL, M, L is 0, KL, M is 0, N is also equal to 0. So that will now be our final conclusion. So there you have it. That's how we will be checking whether an argument is an invalid argument. So just a recap to show that an argument is invalid. We have our premises, we have our conclusion. We will now set our conclusion to be false, and then we will set each premise to be true. So we will try to analyze the propositions given so that we satisfy these conditions. That the conclusion is false, each premise is true. To make the argument invalid. Now, if we cannot come up with this, then it means the conclusion is a valid, or the argument is a valid argument. So that's it for this video lecture. Till our next lesson. So God bless everybody. Stay safe, stay home, and again, manage your time wisely.